Hello, I'm Catherine Weatherburn, the founder of Safetyknot, and we work with construction companies and organisations who have construction elements in their projects. And we do this with the aim to promote safety and to prevent injury. In this video, we're going to discuss the concept of risk in relation to construction sites. Now, you know your community best, and you'll likely know whether your community do or do not understand some of the risks involved in the work they do, or if they do understand the risks but they're not following safety practices. Why is this? It could be because of other considerations, which, as I say, you'll know best. But in this video, we're going to look at two tools, a health and safety risk assessment and the hierarchy of controls. And I hope that you'll find these helpful to use when discussing risk with your community, and it might give you some more insight and information about why the workers that you work with are working in the way that they are. According to the Health and Safety Executive, the HSE in the UK, every year many construction site workers are killed or injured as a result of their work. Others suffer ill health such as musculoskeletal disorders and dermatitis, for example. The hazards, though, are not restricted to people working on sites. Children and other members of the public are also killed or injured because construction activities have not been adequately controlled. The construction injury is often referred to as a high-risk setting, which also is the case in Great Britain, even though, according to the Health and Safety Executive, it's one of the safest places to work in the world. In fact, in the UK, construction has one of the highest deaths of any industry. You can see that in 2022 to 23, there were 45 deaths in construction, followed by agriculture, forestry and fishing, accounting for 21 deaths, and manufacturing for 15. And now, if we look at the three most common causes of fatal injuries in construction in the UK, we can see that they are falls from height, being struck by a moving object, and being struck by a moving vehicle. So we can see that construction can be high risk. But what can be done to reduce this risk to workers? Well, firstly, I want to start by saying that risk is part of everyday life, and we should acknowledge that it's not possible to eliminate all risks in any situation, including on construction sites. But what is important is to identify the main risks and the mitigation measures or safety control measures that can be implemented to manage these risks responsibly. The HSE say you need to do everything reasonably practicable to protect people from harm. So what does this mean so far as reasonably practicable? Well, this is going to look different in every context, but the idea remains the same, which is to balance the level of risk against the measures needed to control the real risk in terms of money, time, or trouble. So, for example, you do not need to take action if it would be grossly disproportionate to the level of risk. But equally, action does need to be taken where it is reasonable and practical to do so. So I wanted to share two tools with you which I hope you'll find helpful when working with construction workers to identify risk, and then to navigate this risk and reduce it where reasonable and practicable so that you can protect people from harm. So let's begin by looking at a risk assessment. Here's an example on the screen. And a risk assessment is about identifying and taking sensible and proportionate measures to control the risks in a workplace. So for in this context, in a construction site. And these should be conducted for all activities on construction sites prior to work taking place, so before work starts. Risk assessment should be suitable and sufficient and should be tailored towards specific activities, procedures and materials on a construction site. It's also worth bearing in mind that this shouldn't create huge amounts of paperwork. Remember, this should be reasonable and practical to do. And it's worth noting that risk assessments can be very subjective. And if two people are conducting them, their risk assessments could be different. So if I conduct one and you conduct one, then ours could both be different, even though we're looking at the same thing. And that's because risk perception can vary from person to person. So I like to think of a risk assessment as a safety thinking tool. Using this risk assessment helps us to identify hazards and enables people to think about how these hazards may present a harm or risk to people. Conducting a risk assessment helps to identify who may be harmed, how likely it is to happen, and if it were to happen, how severe the harm could be. Identifying this enables consideration to be given about how to manage these risks using control measures. Completing the risk assessment process results in a risk rating, which can then be assessed to decide whether this is an acceptable level of risk or if this risk should and can be reduced further. As I said, risk assessments can be subjective, and that's because people's risk perception varies from one another. So that's why at Safetyknot, we think it's a good idea to conduct risk assessments in pairs or small groups so that you can gain other people's opinion. Conducting risk assessments in this way also provides the opportunity for discussion about risk and safety amongst workers prior to construction starting. So thinking about who should conduct a risk assessment, well, the health and safety executives say that a risk assessment should be conducted by a competent person. But what does this mean? Well, they classify someone who is confident as having sufficient training and experience or knowledge and other qualities that allow them to assist in this process properly. The level of competence required will depend on the complexity of the situation and particular help you need. So if something's more complex, someone perhaps needs to be more experienced. And as I said, in our experience working with many organisations, we think it's a good idea to conduct risk assessments in pairs or small groups. And these potentially could be technicians, safety focal persons, user committees, or anyone else really that you think will need to be aware of the findings of the risk assessment. Because remember, this is a living document. It's something that's supposed to be used and people should be involved when creating it. And that's why we think that relevant stakeholders should be part of this process from the beginning, so that everyone is aware of the risks on site and safety control measures that need to be put in place and adhered to. So when should a risk assessment be conducted? Well, as I said, we think it should be conducted prior to starting work. This is because it provides the opportunity to visualise the potential risks and put in place appropriate safety control measures to keep everyone's site as safe as possible. Conducting a risk assessment at this stage also enables visualisation of whether adequate safety control measures can be put in place. For example, if the intended location is deemed too high risk for construction, an alternative location may need to be identified. Risk assessments should be regularly reviewed. Remember, I said they're a living document, because sooner or later, new equipment, substances, or procedures will be brought in that could create and lead new hazards. A risk assessment should be conducted again when construction work commences, when it starts, and again if there has been a significant change, such as change of site, for example, due to a landslide, or if the construction approach changes, such as opting to use an excavator rather than manual labour, for example. Regularly reviewing risk assessments enables new information to be incorporated. For example, workers may have spotted a problem, or if lessons have been learnt from any accidents or near misses that have been reported, these can then be incorporated, which is why it's so important to make sure your risk assessment stays up to date. And remember, as I keep saying, it's a living document. But I just want to share a note of caution that just because a risk assessment has been conducted, this doesn't make the site any safer. It's only if the risk assessment is acted upon that it can reduce risk for identified hazards. So how do you conduct a risk assessment? There are lots of different risk assessments. This template that you can see is one that a partner organisation uses. And what we're going to do now is we're going to work through an example from a construction site. But as we've discussed already, it's not possible to eliminate risk entirely. But conducting a risk assessment enables identification of hazards and associated risk and a potential severity and likelihood. This results in a risk rating, which can then be assessed to decide whether the risk rating is acceptable or if safety control measures need to be put in place. And also to decide what appropriate safety control measures should be put in place. We'll also be thinking about the hierarchy of controls. But before we move on to that, I'd like us to look through the section. So you can see in the screen beside me, there's the little matrix, the risk matrix, there's red, yellow, and green. So this is the section that we're going to be looking at. So firstly, step one, we want to identify the hazard, and I'm using the example of noise from a jackhammer. Step two, we need to identify the risk of this hazard, and the risk that I've identified is hearing damage. Step three is we need to decide what severity it would be if it were to happen. So the risk rating is from 1 to 5. 1 is the lowest and 5 is the highest. So I've decided, in my personal opinion, because remember I said risk assessments are subjective, you may have a different thought on this, I decided that the severity level is 4. It could be a serious injury. So now we need to step 4, decide how likely it is that this will occur. So again, we've got rating from 1 is the lowest, 5 is the highest, the likelihood. So before we were looking at the severity, now we're looking at likelihood. So the likelihood, without using hearing protection for a prolonged period of time, I think it would be 4. And again, you may think differently, but this is a subjective risk assessment. So 4, I think it will be probable. So what we then do here, step 5, is that you multiply the severity by the likelihood to get the risk rating. So this would be the same if you're using it for a different construction focus as well. Therefore, if the severity is 4 and the likelihood is 4, then we multiply it together, meaning that the risk rating is 16. Now, where does that fall? That falls in red. So number 6, what colour is the risk rating? So as I just said, it's red. So green symbolises lower risk. Yellow symbolises medium risk, red symbolises higher risk. Sometimes you'll see this worded a bit differently, but ultimately you ideally want the risk to be in green. There's still risk there, because as I said earlier, we can't ever eliminate risk fully, but we can decrease it so that it's an acceptable level of risk. Yellow, if it's there, it's something that we can see is still risky. It would be better if it could be green if possible. Red means it's high risk activity, which of course doesn't mean it might not happen, but ideally you want to put control measures in place to make it safer. So we're falling in red, 16. So step 7, is this risk rating acceptable? So it's red, it's 16. Ideally, as I said, we want it to be green, but no, I don't think this is acceptable. Therefore, I need to see what safety control measures I can put in place to make this risk rating more acceptable. What can we do to change the risk rating? So step 8 is safety control measures. So the hazard is noise from jackhammer use. So what safety control measures can I put in place to protect from the hazard of noise and the risk of hearing loss? Well, I've decided that that would be adequate ear protection. So now what I'm going to do is I'm going to repeat that process, thinking about, I've identified the hazard of noise from the jackhammer. I'm going to put adequate ear protection in place. Now let's check again what the risk level is acceptable. So step 9, we rate it from 1 to 5, and I've decided that it would be 2. It would cause a minor injury if we were to continue with this adequate hearing protection. And step 10, then we're looking at the likelihood. So before we were looking at the severity, now we're looking at the likelihood. 1's the lowest, 5's the highest. The likelihood I'm saying is 3. It could be possible. So then what we do is we do our maths and we multiply the severity, which is 2, and the likelihood, which is 3. We multiply it together to make the risk rating of 6. So is this acceptable? Well, let's have a look. So before, remember, it was red, it was 16. When we times 2 and 3 together, we get 6. It's now in the green area, which, as I said to you, is acceptable level of risk. Remember, we can't remove risk altogether, but we can reduce it. So step 12, I've decided it's in green. That's a lower risk. And I've decided that, yes, this is an acceptable level of risk. So you would repeat this for each activity that's going to be taking place on site. And you would continue to do this, as I say, if something changes, if the method of work changes, if the site location changes, for example. Remember, it's a living document. Make sure it's up to date. Make sure those who are involved in it ideally are the ones who are filling this in and completing it. But if they're not, then at least they're very aware of what's in place and why. So now what we're going to look at is the hierarchy of controls, because I said when we decide what appropriate safety control measures should be put in place, then we can use the hierarchy of controls as a thinking tool. So this is the hierarchy of controls. So as we can see, elimination is at the top and it's the most effective. And then you would work your way down to the bottom of the hierarchy, which is the least effective. So the most effective, as I said, is control. The most effective control is elimination by physically removing the hazard. The second is substitution by replacing the hazard. The third is engineering controls, which isolates people from the hazard. The fourth is administrative controls, which makes change to the way people work. And the fifth is the least effective, which is PPE. And PPE is personal protective equipment, which is designed to protect the worker. Okay, so let's look at what this means by using some examples. Looking at the top of the triangle beside me, elimination. When conducting the risk assessment, it's identified that there will be an 800-metre stretch of cliff, which requires construction workers to work at height. To avoid working at height, which is known to be a high-risk activity, they could perhaps find an alternative route to lay the pipeline. It may be that this option is not preferred, as it may mean the cost is higher and the work takes longer. But if an alternative route can be identified that eliminates the need to work at height, then we've been able to remove the highest hazard and use the most effective safety control, elimination. It's worth noting that it's usually less costly to implement the elimination step at the design or development stage, rather than changing route or process after the work's begun. And again, this is why it's so important to conduct a risk assessment prior to starting work and to use it alongside the hierarchy of controls. Another example could be when painting buildings. Use a reach and paint system to paint walls rather than using a ladder, which eliminates the need to work at height. Remember, according to the HSE, that in the UK, falls from height are the most common cause of fatalities on construction sites. So now if we look at the next step down to a substitution, if working at height cannot be avoided, such as when painting the outside of a multi-storey building, for example, then where possible, use an existing safe place to conduct the work. So this could be a balcony. Now 3, we look at engineering controls, we're working our way down. If there is no such existing safe place to conduct work from, such as a balcony, then prevent falls by using guarded platforms or edge protection. Then if we continue to work our way down, engineering controls are favoured over administrative controls and PPE, because you can see that they're least effective as we keep going down, as they are designed to remove the hazard source. Now, the initial cost of engineering controls can be higher than administrative and PPE controls. But interestingly, actually, over time, over longer term, they may actually work out as a lower cost. So this is really worth considering if it's possible, and also speaking to the person in charge with the budget about this. And then looking at administrative controls, anyone who's working at height should be fully trained and experienced. Training should not be limited to knowing just how to climb and work at height, but how to do so safely. And such training should also include how to work safely and the correct use of the equipment in accordance with the manufacturer's instructions. So now we've worked our way to the bottom of the hierarchy of controls to the least effective personal protective equipment, PPE. If no other safety measure controls can be implemented, the final measure in preventing falls while working at height is the use of PPE, such as a fall restraint system. This system typically uses an anchor point and lanyard adjusted or set to a fixed length to prevent the user reaching a hazard. And this would be in addition to other required PPE, such as safety helmets, gloves, safety goggles, and appropriate footwear. The hierarchy of controls demonstrates that PPE is the least effective control measure and should only be used as a last resort measure. This really challenges the common perception about PPE, such as hard hats and high visibility, which are often viewed as synonymous with safety. So in this video, we have discussed that whilst it's not possible to eliminate risk entirely, tools such as a risk assessment and hierarchy of controls can be utilised to identify hazards and decide whether and what safety control measures can be implemented. However, even if these are conducted and implemented, the communities that you work with may not adhere to the safety control measures that have been put in place. Now, this could be due to many reasons or factors, including speed of work, comfort of equipment, ease of use, lack of training in how to use the equipment, different ideas about risk and hazards, and that would be the different risk perception from person to person. There are many possible reasons why, and you know your community best. So you may already know the answer to some of these. If that's the case, or not the case, then it's better to ask workers why. Why are you not using or implementing the recommended safety control measures? And then, depending upon the reasons for this, a plan of action can be put together so that workers are protected from harm.